Next one is conversion of fractions of decimal number in base 10 to base 2. Okay, how do you convert fraction? Decimal numbers in base 10 to base 2. So what we want to do, okay, so example 1, convert. How do you do that? So let's look at this example. Convert 9 whole numbers 7 over 8 in base 10 to base 2. This is a mixed number. It has a fraction, has a whole number and have a fraction, and it's in base 10. I want to convert it to base 2. So how to do this is this solution. First of all, we have to treat the whole number first. Remember, we are converting to base 2. We have to convert the whole number to base 2. And converting a number in base 10 to base 2, use the LCM method, which I have taught before. Look up for where I've teach it, and then relearn it if you didn't get it well. So now we've got 9 in base 10, so 2 can go into 9 4 times, remainder 1. 2 can go into 4 2 times, remainder 0. 2 can go into 2 1 time, remainder 0. And then 2 can go into 1 0 time, can go into 1, so 0, remainder this 1. So you copy your answer upward. 1001 is the answer. So therefore 9 in base 10 is the same thing as 1001 in base 2. Now we are done with the whole number part. We've convert 9 in base 10 to base 2. Then what of 7 over 8, which is a fraction part? So you have to convert it to base 2 too. So for you to convert this to base 2, it needs to, you have to ensure that this particular value, which is the numerator 7, has to be splitted. You need to split it into a number that can has a power of 2. Into a number that can have a power of 2. Now let's go now. You see 4 plus 2 plus 1 will give us 7. So we can find the power of 2 raised to power something can give us 4. So the number we are splitting the numerator to should be a number that 2 raised to power of will give you back that number. So 2 raised to power of something will give us this. 2 raised to power of 2 will give us 2 raised to power of something will give us 2. 2 raised to power of something will give us 1. So example, I can decide to say, let me use maybe 5 plus 1. 2 raised to power of something can give me 1, but what of 5? 2 raised to power of what will give me 5? I cannot find. So the basis for splitting number here is that any number you are splitting the numerator to, using this method, it has to be a number that 2 raised to power of that number will give you that very number you are splitting this 7 to, because here we have base 2. All right, so let's go. If you are operating in base 3, so it has to be the same thing as any number that you are splitting the number to 3 raised to power. A certain number should give you that number. So now 4 plus 2 plus 7 will give us 7, plus 1 will give us 7 rather. So therefore 4 over 8 is the same thing as this whole thing is the same thing as 4 over 8 plus 2 over 8 plus 1 over 8. So by the time we reduce 4 here, 4 into 4, 1, 4 into 8 is 2. So 1 is 1. That is why we have 1 over 2 plus 2 here, 1. 2 into 8 is 4. So that's why we have 1 over 4. Then 1 here is 1. 1 into 8 is 8. So that's why we have 1 over 8. So now what we are going to do now is we are going to be multiplying out this value we have now. We are going to be using 1 to multiply each of them. You see, 1 times 1 over 2. This is the method. And then by the time you do that, you discover that the power is also starting from 1, plus 1 times, because this is 2. This 2 here is 2 raised to power 1, but we don't have to put the 1. So, but I just indicate the 1 here so that you know that it is 2 raised to power 1. Then the next one, we introduce 1 again. 1 times 1 all over, instead of 4, we now wrote 2 raised to power 2. Why? Because 2 raised to power 2 is still the same thing as 4. Then plus 1 times 1 over 2 raised to power 3. Why is it 2 raised to power 3? Because here is 8. So 2 raised to power 3 is still 8. So this is the same thing that equals to 1. 1 is the same thing as 1 times this 1 over 2 raised to power 1 is the same thing as 2 raised to power 1 minus 1. Why is it? I told us before that whenever you have minus 1 like this, it means 1 all over. Okay, so if you are writing this in power, this is what you'll get. Then if you don't understand this, you look up for the video that where I explain this. Plus this 1 times 2 raised to power minus 2. Because 1 all over here means minus, so this 2 raised to power 2, the minus will come in between. 1 all over here will bring the minus in between, so this is a minus, plus this 1 here times 1 all over 2 raised to power 3 is the same thing as 2 raised to power minus 3. So here we have to put our dot. What we are going to be writing is this 1 they are our answer. Okay, so but you have to take note of something in the next example I'll be sharing. This is raised to power minus 1, this is minus 2, this is minus 3. So there is no number that is omitted, no power that is omitted. So that is why we didn't include anything. So but in the next example, you discover that some powers will be omitted, and I will show you why. So since no power is omitted, the answer to this is, since it's minus, we put dot, bring this one down, 1 of this one down, 1 of this one down. So it's going to be, if you have dot 1 1 in base 2, 1 1 1 in base 2 is the same thing as 0.111 in base 2. So therefore 9 whole number 7 over 8 in base 10 is the same thing as 10001, okay, which we have already converted from here. Look at it here. Then apart from then plus the fraction part, which is dot 111 in base 2, which is in 0.111 in base 2. If you add this to this, it's going to be 1110.111 in base 2. You have done that. Now let's look at this example too. Very, very interesting example that will help you to understand more. Convert 57 over 64, all in base 10 to base 2. Here there is no whole number again, so we don't have to convert the whole number first to base 2. So we are dealing with the fraction straight. How do we split 59, okay, into numbers? Because we are converting to base 2, into number that 2 raised to power of something can give us the number. Example, 2 raised to power of what can give you 32? Of course, you can find. So you discover that 32 is a perfect square. 16, 8, 2, and 1. If you add all of this together, it will give you 59. You see, you have to carefully select your number. And the guide to select this number is that this number that you are selecting must be number. And by the time any one of them here, 2 raised to power of something, the base is the 2. We are converting to base 2. So 2 raised to power of what should be able to give us 2 raised to power of something should be able to give us this. 2 raised to power of something should be able to give us 16. 2 raised to power of something should be able to give us 18. 2 raised to power 8. 2 raised to power of something should be able to give us 2. 2 raised to power of something should be able to give us 1. So therefore, if you have gotten all of these numbers splitted like this, then discover that this is the same thing as these whole steps. So 32 over 64. So we split the denominator between the numerators. So that's what we do here. 16 over 64, 8 over 64, plus 2 over 64, plus 1 over 64. Okay, so what you are going to have here now is, you are going to have, if you 32 here, 1, 32 here is 2. So we just reduce it. We are reducing it. 16 here, 1, 16 here is 4. 8 here, 1, 8 in 64 is 8. 2 here is 1, 2 in 64 is 32. Then 1 here, 1 is 64 is 64. So we just reduce so that it will help us to get the appropriate power. All right, are we together? Then the next thing to do is this. We have 1 over 2. So this 1 over 2, you need to bring out 1. You need to bring out 1. By the time you bring out 1 to multiply by each of them, all right, you need to use 1 to multiply by each of the 10. By the time you come to this point, you need to use 1 to multiply by each of them. So you introduce 1 times 1 all over 2 is the same thing as 1 all over 2 raised to power 1, okay, plus we introduce 1 again times, if you introduce this one, nothing changes, because 1 times all of this value, it will still give you this value. All right, so 1 times anything doesn't change anything, so you introduce 1 all through, which will actually become your answer. Then plus this 1 again times 1 all over 4 is the same thing as 1 all over 2 raised to power 2. 2 raised to power 2 is 4, so it's 1 all over this. Okay, so that is what you are going to get. Then plus 1 times 1 all over 2 raised to power 3. 1 all over 2 raised to power 3 is the same thing as 8. 2 raised to power 3 is 8. So 1 over 8 is the same thing as 1 over 2 raised to power 3 plus 1 times 2 raised to power 25. 2 raised to power 5 rather. 2 raised to power 5 will give us 32. Then finally plus 1 times 1 all over 2 raised to power 6. 2 raised to power 6 will give us 64. Okay, so do you notice anything here? You notice that we have raised to power 1, raised to power 2, raised to power 3, then raised to power 5. There is no raised to power 4. So that one that is lost, that raised to power 4 that is omitted, that is not found, we represent it with 0. The gap will be represented with 0. Then from 5 we go to 6. Okay, so this is 1 times 1 all over means minus. So that is why we have 2 raised to power minus 1 here. Instead of 2 raised to power 1, it is not minus 1 because we remove 1 all over. 1 all over means this minus, plus 1 times 1 all over 2 raised to power 2, which is 1 all over means minus. So we change this 2 raised to power 2 now become 2 raised to power minus 2. The same thing happens here. 2 raised to power 3 is now 2 raised to power minus 3. Plus 1 times 2 raised to power 5 here means 2 raised to power minus 5 plus 1 times 1 over 2 raised to power 6 is the same thing as 2 raised to power 1 times 2 raised to power minus 6. Okay, so note, note that 2 raised to power 4 is missing in the above. This means that it is multiplied by 0, because anything multiplied by 0 is 0. That is 1 times 2 raised to power 1 plus 1 times 2 raised to power 3 plus 1 times 2 raised to power 3, then plus, this is what I'm talking about. Look at it here. Since we don't have 4 here, after 1 times 2 raised to power 3, we go to 1 times 2 raised to power 5. In between 1 times 2 raised to power minus 3 and 1 times 2 raised to power minus 5, there is 1 times 2, there is something times 2 raised to power 4 minus 4, and that thing is 0. Look at it, 0 times 2 raised to power, because 0 times this whole thing is still 0. So we just put it to fill in the gap to make sure that the trending of minus 1, minus 2, minus 3 will not be caught in between here. We have to fill in. Okay, so that's what you are expected to learn here. So therefore, 1 times 2 raised to power minus 5 plus 1 times 2 raised to power minus 6. So the answer is going to be, since this is starting with minus, 1 times 2 raised to power minus 1, so we have dot. This one is our answer. The next one is our answer. This one is our answer. The next one is 0, which is our answer. The next one is 1, which is this one, which is our answer. The last one is 1, which is this one, which is our answer. So all of these things, 59 divided by 64 in base 10 is still equals to is the same thing as 0, because anything dot, 1 dot, before dot there's 0 in mathematics. Either you write it dot something, dot all these things, or 0 dot. So 0.111011 in base 2 is the answer to this. Okay, so which is the same thing as this example. Express 0.5625 in base 10 as a binary number. In base 10 as a binary number. So first convert 0.562 solution now. Convert 0.5625 in base 2 to fraction. This thing is a decimal. This thing is given to you in decimal. So you have to convert it to fraction. If you have it in a decimal form, convert it to fraction, because you already know how to convert fraction to binary number. Okay, so now to convert this to fraction is the same thing as 5625 all over 10,000. Okay, if you divide this by 10,000, how we do it is 0 here, under this point is your 1, under this point is this 1, the remaining number is now becoming 0. 5 is 0, 6 is 0, 2 is 0, 5 is 0. So that is why we have 1, 0 for 5, 0 for 6, this 0 for 2, this 0, 0 for 0, this 0 is for this, for 5, 0, this 0 is for 6, this particular 0 is for 2, this particular 0 is for 5, this 5. So that's why you have up to this 0. Then this point is this 1. Okay, so therefore 5625 divided by this will give you back this decimal. So if you reduce this number now, 5625, okay, if you reduce it, you discover that it is still the same to be reduced by 9 all over 16. 9 over 16, you reduce it to the lowest 10. This is the lowest 10 of this particular number. So we are going to convert 9 over 16 in base 10 now to binary. Binary. So to do this, of course, we have to split this 9. So 8 plus 1 direct will give us 9. So 9 over 16 is the same thing as 8 plus 1 over 16, which is equals to 8 over 16 plus this 1 over 16. So 8 here is 1, 8 here in 16 is 2. So we have 1 over 2, and this plus is what we have here. Then 1 here is 1, 1 over 1 into 16 is still 16. So we have 1 over 16. So this is going to be equals to, we have to start introducing 1, use 1 to multiply each of these 10. So 1 times 1 over 2, 1 over 2, which is a method, 1 over 2 raised to power 1 plus 1 times 1 over 2 raised to power 4. Why is it 2 raised to power 4? 2 raised to power 4 is 16, and we have 16 here. That is why it is 2 raised to power 4. Okay, so now this is the same thing as 1 times 2 raised to power 1. 2 raised to power 1 is the same thing as 2. Look at this 2 here. It's the same thing as 1 over 2 raised to power 1, because I told you 1 over 1 is already minus. This minus take care of it. Okay, 1 over is the minus take care of it, plus 1 times 2 raised to power minus 4. It is raised to power 4 here because 1 all over is still there. But if you remove the 1 all over, this minus will take care of it. So discover that let's look at the trend now. We have minus 1, then we now have minus 4. So from minus 1 to minus 4, you discover that something is missing. Minus 2 is missing. Minus 3 is missing. So in between minus 1 and minus 4, there are two values that are missing there in their power. So note that 2 raised to power 2 and 2 raised to power 3 are missing. This means that they are multiplied by 0. So what it means is that 9 over 16 in base 10 is the same thing as 1 times 2 raised to power 1 times, we have to bring the 0 now, to feed the missing links. So 0 times 2 raised to the power minus 2, which is not there before, we just introduce it. Why? Because 0 times 2 raised to the power minus 2, it is still 0. Okay, so it doesn't mean anything. So we just bring it to fill in the gap. Okay, so 0 times 2 raised to the power minus 3 plus 1 times 2 raised to the power minus 4. So the answer now is going to be this 1, is going to be this 0, 0, and 1. So the answer is going to be dot. Remember why we put dot or point is because we are starting with negative value. Whenever you have a negative value, it is point. It shows that how to indicate it is point. Okay, it's point, it's fraction or decimal. Okay, so next is pick this one, dot 1. Next one is 0. I have this 0 here. The next one is 0. That's why we have this 0 here. The next one is 1. This one, that's why we have this one here. So all of this value in base 10 is equals to 0.1001 in base 2. Okay, so this is how it is done. We also have similar example here. Convert 0.123 in base 4 to Big-Zima. What is Big-Zima? Note solution now. Big-Zima is to base 2. Okay, that is Big-Zima is equals to base 2. Right, so we can use binary, we can use base 2, we can also use Big-Zima. So take note. In case they use any of this language for you, you need to take note. So of course, the method of solving this one is similar. Okay, the method is quite similar. All right, the method is quite similar. Okay, so now that the method is quite similar, I want you to look at this. By now you should be able to do this if you follow the video very well. Let me run over it for you. Now if we are converting this number, remember the number is in base 4. If you are converting it to base 2, you need to first of all convert to base 10. By the time you convert to base 10, then from base 10 to base 2. So this is the number in base 4. Then to convert this to base 10, we use expansion method. Effect 0 times 4 plus 1 times 4. 1 times 4 plus 2 times 4 plus 3 times 4. Then from here we have the point. The point is in between 0 and 1. So the 0, the power is going to, we start 0 to the left. There's no number again there, so it's 0. Then plus to the right now we have 1. So this 1 times 4, we start with minus 1 because it's now behind the point. Minus 1, minus 2, then minus 3. So we have 0 times 4 raised to the power 1 is 4 raised to the power 0. Anything raised to the power 0 is 1, plus we have 1 here. This 1 times this minus 1 means 1 all over. So it's 4. 1 all over 4 plus 2 times 4 raised to the power minus 2 is the same thing as 1 all over 4 raised to the power 2 plus 3 times 4 raised to the power minus 3 is the same thing as 1 all over 4 raised to the power 3. So 0 times 1 is 0 plus 1 all over 4. Why is it 1 all over 4? 1 times 1 all over 4 is 1 all over 4 plus 2 times 1 is 2. Then all over 4 raised to the power 2 is 16 plus 3 times 1 is this 3. Then 4 raised to the power 3 here is 16 equals to 0 times all plus all of these things is still the same thing. So we remove the 0 totally. This is going to be equals to the LCM of 64, 16, and 4 is going to be 64. Is 64. Okay, so write 64 down, put your long division line on top. So 64 divided by this 4. 64 divided by 4 is 16. 16 times 1 is still 16. So that is why we get 16 here. Plus 64 divided by 16 is 4. 4 times 2 is 8. So we have 8 here. Plus 64 divided by 64 is 1. 1 times 3 is this 3. 64 plus 8 plus 3 is 27 all over 64. So you discover that, 16 plus 8 plus 3 is 27 all over 64 in base 10. Now we have this number in base 10, so we have to convert it from base 10 to base 2. Now, okay, convert the base 10 to base 2. This is what is obtainable. 27 over 64. You have to split this 27 into number that if you add them together, they will still give you back 27. Remember, bear in mind that the guide is the base 2. Any number you are splitting to, 2 raised to power something should be able to give you that number. Okay, so we have 16, 8, 2, and we have, most of the time we use even number, and then 16, 8, and 2. 16 plus 8 plus 2 is plus 1 is 27 all over 16. So you have to split the denominator with them. So 16 all over 64, 8 all over 64, 2 all over 64, 1 all over 64, 16 here, 1, 16 in 64 is 4, 16, 8 here is 1, 8 in 64 is 8, 2 here is 1, 2 in 64 is 32, then 1 here is still 1, 1 in 64 is 64. So now we have to introduce 1 to each of them. 1 here, 1 here, 1 here, and 1 here. Okay, so we must use 1 to multiply them to each of them. So 1 times 1 all over 4. Instead of writing 1 all over 4, it's still the same thing as writing 1 all over 2 raised to power 2, because 2 raised to power 2 is 4, plus 1 times 1 all over 2 raised to power 3, because 2 raised to power 3 is 8. Instead of writing 8, you see, we are now using 2 now to get their power. So the next one is 1. We introduce 1 times 1 all over 2 raised to power 5. Because 2 raised to power 5 will give us 32. That is 2 times 2 times 2 times 2 times 2. Alright, so plus 1 times 1 all over 2 raised to power 6. 2 raised to power 6 will give us 64. Okay, so if this is the case, then what we have here is, note, we have if you look at this, we have minus 2. There is no minus 1. Minus 1 is missing. Minus 3 is there. Minus 4 is missing. Minus 5 is there. And then minus 6 is there. So note, minus 2 raised to power minus 1 and 2 raised to power minus 4 are missing. So therefore, this 27 over 64 in base 10 is going to be equal to 0 times 2 raised to power minus 1. You see, we introduce the 0, then 2 raised to power minus 1, because it's not, 2 raised to power minus 1 is missing. So we now go to 2 raised to power minus 2, 1 times 2 raised to power minus 2, plus 1 times 2 raised to power minus 3. 2 raised to power 4 is missing from here, so we introduce 0 times 2 raised to power minus 4, just for 2 raised to power minus 4 to reflect, plus 1 times 2 raised to power minus 5. Okay, so 1 times 2 raised to power minus 5 plus 1 times 2 raised to power minus 6. 1 times 2 raised to power minus 6. Then by the time we have this, we pick each of the value here as the answer. Dot 0.0, 0.1, so look at point because of the minus. 0 is 0, 1, this 1 here, 0 is 0 here, this 1 is gotten from there, then finally this last one is gotten from here. So all you need to do is to, when you have points, it's not good to leave your answer like this. You put extra 0 point, it's still the same thing in base 2. Okay.